Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Venus. When we picture our closest planetary neighbor, we usually picture hell. A dense, toxic atmosphere, eternal crushing pressure, and surface temperatures hot enough to melt lead. It's a world utterly inhospitable to life, dominated by active volcanoes and thick sulfuric acid clouds. But tucked away in the upper reaches of this planetary inferno is one of the solar system's most peculiar meteorological phenomena. Sand that condenses out of thin air. A process scientists call the Silicate Whisper. This isn't a gentle dust storm. It's a form of high-altitude mineral snow created by extreme atmospheric chemistry, and it offers vital clues about Venus's deep history and surface composition. To understand this bizarre phenomenon, we must first appreciate the extremity of Venus's environment. The average surface temperature is over 460 degrees Celsius. In this environment, minerals that are solid on Earth, like certain silicates, sulfides, and heavy metals, can be vaporized, becoming gaseous components within the atmosphere, just like water vapor on Earth. The constant, intense volcanic activity on Venus acts like a massive chemical refinery. When volcanoes erupt or lava flows, they release gases rich in sulfur, chlorine, and various metal compounds. More importantly, the extreme heat causes minerals, including silicates from the rock itself, to sublimate or react violently with atmospheric gases. Now, let's trace this vaporized material upward. The atmosphere of Venus is incredibly thick, nearly 90 times the pressure of Earth's at sea level. This immense density acts as an effective transport mechanism. The superheated gaseous minerals and their chemical compounds, elements like tellurium, bismuth, iron sulfides, and potentially heavy silicates, are swept up into the higher altitudes by powerful thermal currents. As these gaseous compounds ascend, two critical things happen. The temperature drops significantly, and the pressure changes the chemical dynamics. The high-altitude regions, specifically above about 3,000 meters, are dramatically cooler, even though they are still far hotter than Earth's surface. This cooling causes the vaporized minerals to reach their dew point, but instead of condensing into liquid water, they condense into microscopic, solid mineral particles. They crystallize, forming what is essentially mineral sand, fine dust, or, more commonly, a kind of bizarre, chemical, snow. This is the Silicate Whisper, a perpetual, gentle fallout of exotic, metallic dust. This condensation isn't just theoretical, we have physical evidence. For decades, radar observations of Venus, specifically data from the Magellan mission, revealed that the planet's highest peaks, such as the massive Maxwell-Montes mountain range, are intensely bright and reflective in radar scans. They are far brighter than the plains below them. For a long time, scientists speculated this bright material was literally metallic frost, a layer of pyrite, iron sulfide, or perhaps crystallized tellurium. This earned it the nickname, metal snow. However, recent atmospheric modeling has refined this picture, suggesting a complex mixture of condensed compounds that include heavy metal silicates. The reflectivity is due to this exotic frost. Imagine a snow line on Earth, but instead of frozen water, it's a layer of condensed, exotic minerals blanketing the mountain caps. Because these peaks are the only places high enough to reach the necessary condensation temperature and pressure zone, they are the only places where this sand accumulates. Crucially, this Silicate Whisper is more than just a weird weather report. It provides invaluable data on the global cycling of materials on Venus. It tells us that the surface rocks are actively being chemically processed by the atmosphere and redeposited. The specific composition of this metal snow, whether it is dominated by tellurium compounds, lead sulfide, or complex silicates, is a direct fingerprint of the underlying geology and the chemical processes happening in Venus's lower atmosphere. Understanding how Venus manages to cycle solid rock materials through its atmosphere gives us deeper insights into extreme planetary climate dynamics. It demonstrates that atmospheric chemistry can reshape surface geology dramatically, even in the absence of liquid water. This knowledge is essential as space agencies plan future missions, like NASA's Da Vinci Plus and ESA's Envision, which aim to pierce the Venusian veil and finally decode its mysterious past. If we ever send a lander to these high plains, it might not find typical loose rock and dirt, but a surface coated in a perpetually refreshing layer of chemically manufactured mineral snow, created entirely out of thin air. For more incredible facts like this, don't forget to subscribe and turn on notifications.